The last part of section 3.3 is higher order derivatives. So I pre-wrote some things out, obviously. We already know how to do f prime of x, which is the derivative of the f of x. But now we have f double prime and f triple prime and f to the fourth prime, and I'll explain why it's called to the fourth. So the second derivative is the derivative of the first derivative, and the first derivative is the derivative of the original function, and so on and so forth. So you're gonna see some different notation. F triple prime of x, also known as the third derivative, is the derivative of the second derivative. And it's written as, it's not d cubed y. It is the third derivative of y with respect to x. The third derivative of y with respect to x. So we don't use like tick, 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 tick for the fourth derivative. So the fourth derivative of x is written as such. That is not the function to the fourth power. Okay, before I go any further, I heard the best math joke ever. So in this time of shelter in place, unfortunately, there have been a lot of things being canceled. My partner and I had a cruise to Alaska, and that was canceled. And all these, graduation and all these things, unfortunately, are being canceled. But you know what's not being canceled? The A's in A plus B over A. Isn't that awesome? And let's just make a side note. They wouldn't be canceling anyway because that's not a proper math word. But I heard this joke and I thought it was super funny. So you can roll your eyes at me. Ha ha ha. Okay, anyway, we're going to practice finding second and third derivatives. Next section, we're going to realize that second derivatives help us find velocity and third derivatives help us find acceleration. So all these times in your previous math courses, when am I ever going to use this? And your teachers say, well, when you get to calculus, well, here you are. There are definite applications. So like I did for the last video, I'm going to post like what I'm talking about. I'm going to post it as a PDF. So in case you missed something here, or you want to do the PDF along with the video, whatever. So I'm going to start with number 36. Which I have written down so I don't need my book. They give you that y is equal to x plus 1 over x. And they want you to find four derivatives. They want you to find up to the fourth derivative. So it's written as a quotient. So I'm going to do the quotient rule. My whole math calculus life, I've never liked the quotient rule. I've always preferred the product rule. So I'll show you how to do a good check between quotient and product. Okay, so the derivative of y with respect to x, that's a d, sorry, it's not very good, is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so as I said, I've already done the PDF worked out, so I'm going to skip some steps here. And with all my work worked out, this ends up being negative 1 over x squared. Okay, f prime of x, the derivative of y with respect to x. They mean the same exact thing. So how do you know when to use which notation? When we get to word problems, this notation is technically better, but they mean the same thing. So I'm going to use f prime of x more frequently than I use the derivative of y with respect to x. Okay, so the second derivative you could use the quotient rule again. I think the quotient rule is a pain in the butt, as I already said. I'm going to rewrite this as negative x to the negative 2. So the derivative of y with respect to x of, I'm going to use parentheses, negative x to the negative 2. Using the power rule, it is so much faster if you rewrite 1 over x squared as x to the negative 2. This requires quotient rule. This requires power rule. You can be done in one step. So this is 2x to the negative 3. So this is, let me just write this. This is the second derivative. Okay, and then the third derivative, and the fourth derivative, and so on. And I totally, hold on a second, I messed this up. Did I mess it up? I think I forgot the negative sign. No, I think we're good. And then the triple prime is equal to the derivative of the second derivative, which is negative 6x to the negative 4. I made a mistake somewhere here. I'm trying to figure out what I did wrong. No, this is right. Okay, and then the fourth derivative is equal to 24x to the negative 5. So let's rewrite this as 2 over x cubed, negative 6 over x to the 4th, and 24 over x to the 5th. And that is your first derivative, second derivative, third derivative, fourth derivative. So the problem is, if you make a mistake with the first derivative, then all your remaining derivatives are incorrect. So be careful with that. Okay, I'm going to show you how to do the first derivative with the product rule. And it's a good check in case you don't like the quotient rule. So I'm going to do the original problem and find the derivative using the product rule as opposed to using the quotient rule. Okay, so if I want to use the product rule, I need to rewrite y as x plus 1 times x to the negative 1. And it's great practice. So the derivative of y with respect to x is x plus 1 times the derivative of x to the negative 1 plus the derivative of x plus 1 times x to the negative 1. Okay. So to save time, you end up with negative x plus 1 over x squared. Let me write this a little bit cleaner. Already, this takes a lot more steps than the quotient rule. Now you need a common denominator, which is x squared. And when you simplify all of this out, you get negative 1 over x squared, which is the same thing we got by the quotient rule. So which one should you use? If the problem is given to you as a quotient, then you should use the quotient rule. And if the problem is given to you as a product, then you can use the product rule. Why did I do both? Practice, and it's a great way to check your work. Okay, number 48. Just go through a couple different examples. 48 looks very intimidating, but it's not that bad. I'm still thinking about my funny joke. It just makes me laugh. Okay, anyway. They give you, let me write down the equation that they give you. I still can't open the markers, whether we're at home or at school. I'll read through the problem in a minute. Just want to write it down. Okay. So I'm just going to read the problem. The reaction of the body to a dose of medicine can be represented by an equation of the form R equals m squared times the quantity C over 2 minus m over 3, where C is a positive constant right away I think to myself, the derivative of a constant is 0. So keep that in mind. Excuse me. So keep that in mind. The derivative of a constant is 0. Okay, so M is the amount of medicine absorbed in the blood. If the reaction is a change in blood pressure, if the reaction is a change in blood pressure, R is measured in millimeters of mercury. If the reaction is a change in temperature, R is measured in degrees, and so on. Find dr dm. This derivative, as a function of M, is called the sensitivity of the body to medicine. And then it goes on to tell us what we're going to figure out with that in chapter 5. So I want to find the derivative of R with respect to M. Okay, I did this problem 2 ways. I used the product rule. Pause the video, see if you get the same thing as me, or do the work and then check the PDF. Okay, so the product rule, I said, okay, this is m squared times the derivative of c over 2 minus m over 3 prime plus the derivative of m squared times the quantity c over 2 minus m over 3. Okay. So this is m squared. The derivative of c over 2 is 0. The derivative of c over 2 is 0 because it's a constant. This is 1/3 m. The derivative of negative 1/3 m is negative 1/3. The derivative of m squared is 2m. Did I do that right? Yeah. Okay. So this is negative 1/3 m squared plus distribute, and you get mc minus 2/3 m squared. When you distribute, combine like terms and you get negative m squared plus mc. That's one way to do it. Of course, I never pick the easiest way first. I always pick the hardest way first. Another way to do it is to distribute the m squared. So I want to find the derivative of r with respect to m of m squared c over 2 minus the derivative of r with respect to m of, minus from here, and then becomes m cubed over 3. Okay, so the derivative here is this is just mc. The derivative of m squared over 2 is m times the constant c. And then this is m squared. 1/3 power rule, 3 times a third is 1, and then decrease the exponent, and there you go. So you might be wondering, whoa. Over here, I said the derivative of c was 0. Okay, the difference here is that I'm using the quantity c over 2 minus m over 3. And here, if you factor out the c, that's a, a property in the last section, I don't remember. but this right here is c over 2 times the derivative of m squared. So that's why the c is still part of the picture. You can factor out the constant. All right, last one, we're going to do a word problem, everybody's favorite. And we're going to do number 52. And there's a great example of 52, or similar to number 52 in the reading. Okay, this is number 52. Okay, so 52 says, the members of the Blue Boar Society always divide the pavilion rental fee for their picnics equally among the members. Currently, there are 65 members and the pavilion rents for $250. The pavilion cost is increasing at a rate of $10 per year, while the Blue Boar membership is increasing at a rate of 6 members per year. What is the current rate of change in each member's share of the pavilion rental fee? Okay, current rate of change, slope, that's a fraction. We're going to find a fraction. So here we go. All right, so I said that m of x, use whatever variable you want except for x and y. The m of x is the number of members. And initially, there are 65 members, and m prime, the increase is 6 members per year. I think it's per year. Okay, and then I did R for rental. And so I said that the R of 0 was, I think it's 250. And the R prime of 0 is 10. Why 0? Because it's just representing the initial starting point. There were a couple problems that you did in the homework, whatever day it was, and everything was given to you as the f of 2 and the f prime of 2, and the g of 2 and the g prime of 2. It doesn't matter as long as it's consistent. And using 0, I don't know, I guess it just makes more sense. Okay, so I want to find the derivative of, with respect to the cost per member. R is the rental cost, M is the number of members. Okay, so this is going to be by the quotient rule. You might want to write it out. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. I should put the 1 here. All over the denominator squared. Okay, so you do all the plugging in. So the m of x is 65. The derivative of the rental cost is 10 minus the initial rental cost, which is 250, times the derivative of the number of members, which is 6, all over, sorry, I'm like totally in your way, all over the number of members, which was 65, squared. Okay, so do all the plugging in, etc., and you get I think it's like 0.201 maybe, something like that. Okay, so we're talking about dollars per member. So this is 0.201, which is 20 cents. And it's negative. It's negative 0.201. So this means that the cost of the membership is decreasing 20 cents per member per year. Okay. Well, this is not true. It's decreasing 20 cents per year, sorry. It's decreasing 20 cents per year. And that is the end of section 3.3. Again, the PDF will be on Classroom.